Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do another code review for you. This is the code review on the British Airways Data Science Internship task number 2. And so basically in the last video, the last code review and blog post I did was on task number 1, and now we're going to be looking at task number 2. So basically what you had to do was you had to take a CSV file full of bookings, and then you had to make predictions on those bookings, and you had to analyze it. So basically that's what I'm going to do. I'm going to go over the code for you that I used. So the first thing that you want to do is you want to import your libraries. It's going to be pandas that creates your data frames and does data processing. NumPy creates your NumPy arrays and does numerical computations. Matplotlib does graphics visualization, and Seaborn does graphics visualization statistically. So after we've imported some of our libraries, then what we're going to do is we're going to read the file. We're going to use pandas to read the file. So we read the file. It's got 50,000 rows by 14 columns. So that means it's got 14 columns of information, and the target is booking complete. That's your target. So basically what you want to do is you want to get as many booking completes as you can. So we check the shape of the data frame, and it is 50,000 rows by 14 columns. We check the info, and you've got some integers and some objects and some floats. So eventually everything's going to have to be converted to a numeric quantity, and the reason why that is because the computer will not make predictions on objects, so it's got to be converted numerically. We did a describe on all of the numeric columns, so you can see the count, the mean, the standard deviation, the minimum, the 25%, the 50%, the 75%, and the maximum. So what we're going to do now is we're going to create a new column called is weekend to see if the flight day was on weekend. So for I in range len df, if df flight day I equals sat, or df flight day I equals sun, weekend equals 1, else weekend equals 0, is weekend dot append weekend, df is weekend equals is weekend, and then you print the length of is weekend, and it's 50,000, and so that's what you wanted. Now we check df again, and you can see over here we've got another column calling it is weekend. So now what we're going to do is we're going to analyze the target, which is booking complete, and you can see that we have a class imbalance here. We have a lot more zeros than we have ones, so that doesn't look too good. So we do a value counts on booking complete. So zeros was 42,522 and 1 was 7,478. Percentages was 85% 0 and 15% 1s. And now what we do is we check the number of unique values in each column. So each column of data, it will tell you how many unique values that you had. And then so the next column of data, what we say is if the number of unique values is less than 10, then we'll go ahead and print off the unique values, because it doesn't do any good to print off lots and lots of unique values, because one of the columns had over 300 unique values, so you don't want that. That's just going to clog up your program. So now what we're going to do is we're going to find fires. We're going to filter the program only for the people with the booking complete. So you have 7478 booking completes. We check the number of unique values for the booking completes. And then if the number of unique values is less than 10, we print off the unique values so you can see what the unique values are. So now what we're going to do is we're going to encode the feature. So we're going to use sklearn's ordinal encoder. And so all of the features that are objects are going to be converted to numeric values. So now you can see here you've got lots of numeric values instead of the objects. And so now we're going to do a heat map with all the features. And you can see when we do a heat map with all the features, none of the columns of data are very highly correlated. So that's good, because if a column of data is really highly correlated, then you'll probably want to drop that column because you don't want too many columns of data, because that just creates noise into the system. So that's good that none of the columns of data are highly correlated. We look at the correlation. So if you're really into correlations and you want to see the correlation, you can see if it's a negative, then it's a low correlation. If it's positive, then it's a higher correlation. So now what we're going to do is the first thing we're going to do is we're going to delete this. We're going to use TensorFlow. So we're going to install TensorFlow Decision Forest. And then we're going to import our TensorFlow and import TensorFlow Decision Forest. And we're going to print the version of TensorFlow that we're using. And we're using version 2.12. We're going to split the data set. So train DSPD, val DSPD equals train test split, DF test size equals 0.2, random size equals 20. Train DSPD, val DSPD is 4,000 and 1,000. But I could have made the test size 1,000.1, which is what I normally do, but I didn't do it in this occasion. So now we make the label is booking complete. So train DS, and we're going to convert the pandas data frame to a TensorFlow dataset. So train DS equals tfds.keras.pd data frame to tf dataset. Train DS tpd label equals label. And we did the same thing for val. So now what we're going to do is we're going to use gradient boosted trees, and that's where tfdf. So model equals tfdf.keras.gradient boosted trees model. Num trees equals 500, verbose equals 2, and model.fit train ds. So you can see we've got the model here. So we're training it. Now we look at the summary. So now we've got a summary of the model. So now we're going to compile the model. Model.compile metrics equals accuracy. Evaluation equals model.evaluation val ds. Return dict equals true. And then so you're going to print it. And then for name, value, and evaluation times, print f name value for f. So you've got an accuracy of 85%. Now we check the predictions. Predictions equals model.predict val ds is greater than 0.5 as type int 32. Predictions equals predictions.flatten, and then predictions. So now you see here we've got a lot of zeros. We check our unique counts equals NP unique predictions. Return counts is true. Numpred equals zip unique counts. Numpred is 0 is 9790. and 1 is 210. So we check the percentages. Percentage 0 equals numpred 0 over len predictions. Percentage 1 equals numpred 1 over len predictions. So we print off prediction 0 and we print off prediction 1. So prediction 0 is 0.979 and prediction 1 is 0.021. And then what I do is I do a disk plot of the predictions, and so you can see that we've got lots of zeros and not very many ones. So now we check the accuracy. We're using sklearn metrics to do that, and we have 85% accuracy, and then we put it on a confusion matrix, and we can see where it went wrong. So that was it for your gradient boosted trees, and was gradient boosted trees. The next one is random forest, and the only difference between in the code, the only difference between the random forest and the gradient boosted trees is the model name, and random forest and gradient boosted trees, they both got the same amount of values. So I'm not going to go ahead and go over that because it's just redundant information. The only change was the name of the model. And you can see that this is what we use. We use Tensorflow's gradient boosted trees and random forest to make a prediction on this data set with BA. And I was supposed to do a PowerPoint presentation, and when I did the PowerPoint presentation and submit it to Forage, let's see if I can find it. Recent BA customer bookings. This was my PowerPoint presentation, and that was what I did. I submitted to Forage for my BA customer bookings. Number of bookings analyzed was 50,000. Number of bookings complete 7478, which was 15%. And then so I gave them a diagram of the number of bookings, and then I gave them a heat map so they can see the heat map. But what I didn't do, because if you looked at the diagram that they submitted, what they did was they checked features. So they were using sklearn. They were not using TensorFlow. But if you come over here on sklearn under Random Forest, they have something called feature importances. And if you use the sklearn's Random Forest and you did feature importances, then it gave you a nice little chart. It gave you a lovely little chart for feature importances, which is not in here. Oh, here it is. Here's your feature importances. You can see it. This is the feature importances, and you can see it. But I couldn't do that on TensorFlow. I looked in the TensorFlow documentation, and they didn't have feature importances. So even though TensorFlow's Random Forest is the same as sklearn's Random Forest, sklearn does have more novel features than TensorFlow does, but I'm just trying to get into the habit of using TensorFlow. But if I had used sklearn, then I could have put feature importances in there, which I didn't get to use in this instance. So I guess I'm going to go ahead and conclude my code review because I've covered everything that I can cover. And this was what I did for my British Airways data science internship. I was given 2 tasks to complete, and I completed those 2 tasks. So I completed my internship, my free virtual online internship with British Airways. I did it with a company called Forage, and you can do it too if you want to. And so I'll conclude this presentation. Thank you so much for watching my video. Thank you so much for watching my code review. Thank you to my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button.